Okay, hi everyone. Welcome to All Core Devs number 144. Um, we have a long list of merge related stuff to discuss. And then towards the end, also wanted to touch on the executable specs work that's been going on. So I guess just to start with like a quick announcement for everyone, um, we discussed this on the last call and I believe 2 calls ago, but Sepolia is going to be having a post-merge upgrade to set kind of a merge block for peer management. This is scheduled for August 17th. There's a blog post that went out yesterday with all the client releases. So if you're listening and you run a node on Sepolia, you need to upgrade. The upgrade basically just changes peer management. It doesn't add any new features or remove any other functionality. And also the client releases that were advertised for the Goerli proof of stake transition also work for the Sepolia upgrade. And lastly, this upgrade is only something on the execution layer. So if you run a node, you only need to update your execution layer client, not necessarily your consensus layer client. So again, people can check out blog.ethereum.org for just the client releases, but yeah, please upgrade that. Anything from anyone on Sepolia upgrade? If not, we had an upgrade on Prater just a few hours ago, so getting it ready for the merge. I know it seems like overall it went quite well. I don't know, Danny, Perry, do either of you want to give a quick update on what happens on Prater?
I think Perry has a bit more detailed view.
Sure, I can go. So the network was roughly at 90-ish% attestation performance pre Bellatrix for people. Yeah, before Bellatrix. And after we dropped down to roughly 81, 82-ish%, it seems to be stable and holding there, at least according to the tags on Beacon Chain. I think that one client team might have a subset of their validators that need to be updated, but besides that, everyone looks perfectly fine. I guess the missing attestation rate might just be from community run validators that haven't been updated. I haven't heard of any issues. And in general, proposals look healthy. There aren't too many unexpected missed proposals or anything. So I'd say it was a as good as we could hope for upgrade for an unincentivized testnet.
Yeah, that's what it looked like to me as well.
It would be awesome if any validator is running on Prata who hasn't updated. If you could update and get the participation rates back up, it would just be nice to have a bigger buffer when the merge actually happens.
And I believe one of the client teams didn't update their execution layer client. So just a warning, you have to do both. I know that it seems like configuration errors are increasingly, the primary things that we're battling with. So we'll continue to work on guides, but make sure if you're listening to this that you work extra hard on getting both sides of that thing upgraded.
Cool. Anyone else have thoughts about Bellatrix on Prater?
It's probably worth noting that we've discovered that Teku and Prism no longer talk to each other on the network. It's a multiplexer config thing in the latest RC of Prism and will be fixed. It's not actually node related, but the hard fork made it quite clear as we watched all the upgraded nodes disconnect and all the non-upgraded ones also disconnected because they didn't have Bellatrix. So it was actually really good to see that working in that we quickly disconnected peers that hadn't updated, that were formed. And at the moment, there's something like, I don't know, it must be about 40% of the network between Teku and Prism's team nodes that aren't in any way directly connected, and they're routing fine around the gossip through other clients, and it's all just still working, which is actually a really cool experiment. So that's kind of good.
Yeah, I just want to confirm on that as well. We fixed it right away. We were sending the right UI code. So yeah, it should be out in our next week's release.
Yeah, thanks for the quick support on that, by the way. That was awesome.
Sweet. Anything else on Bellatrix or Prater Bellatrix? Okay, and then one more network upgrade. We had Goerli Shadow Fork 6 literally hours ago as well. You want to give us an update on this, Barry?
Yeah, so Goerli Shadow Fork 6 hit TTD earlier today. Just a primer on the network. It's a Goerli Shadow Fork, and roughly 30% of the network was running MEV-boost. It was planned to test MEV-boost through the transition. We were at roughly 97-ish% attestation participation pre-TTD and dropped down to about 94 post. But it seems like the drop isn't really related to the merge, but rather a couple nodes just ran out of disk space, and one or two nodes were still syncing up to head. But otherwise, we look great there. On the MEV-boost front, no real issues noticed, at least from a network standpoint. We did notice that one of the nodes that was farther away, so it was in India, whereas the relayer was, if I'm not wrong, in the US. There was really high latency, but it could be related to the machine itself, like the network card just looks weird. We're not getting great throughput on it. I'll look into the node itself, but yeah, otherwise, I don't think we've noticed any other issues. You can check for on ETHstats to have a live view of what's going on there.
Awesome, thanks. Any thoughts, comments on the shadow fork? Okay, so yeah, things seem to have gone well across the various upgrades. Mikael, you had a whole bunch of things you wanted to chat about, so I think, yeah, we can start going through them. You had two requests for comments on the engine API spec. I'll share the first one in the chat here. Issue 270. Yeah, do you want to give some quick context there?
Yeah, sure. Thanks, Tim. First of all, both of these RFCs, like just a discussion around proposals that we will have after the merge, not for the merge, definitely. And this one, that have been dropped in the chat is about removing invalid block hash. It's basically about replacing the invalid block hash status with invalid status plus latest valid hash set to null. It has been this opportunity has been opened recently by a recent change to the engine API. The other one is about it's more involving. Is payload status is worth reworking? It's actually not like complete rework of them, but making them the payload status is more clear. To allow for CL to distinguish the two states of EL it is communicating with. One state is when EL have to go to the network, pull some data from remote peers to validate a particular payload. And the other state is when it has enough, it has all data required to do the validation locally, but it just needs to make some computation, basically executing like a bunch of blocks to validate the payload in question. As for now, current status is that we have like accepted and syncing. They're a bit vague with respect to these distinguishing between these two states. And this is probably what CLs would like to have to start utilizing this. To start making a difference between accepted and syncing statuses. So I'm just just want to engage CL and DL client developers to look into these two RFCs with their comments. I know you have a lot of things to do, and this is post-merge, but anyway, would be great if more people take a look on them.
Sweet, thanks. Any thoughts people want to share now about either of these? Okay, and yeah, it seems like the second one already has some comments from some CL developers, so I suspect we'll be talking about that on the CL calls as well. Okay, I guess the next up, you also had a PR about checkpoint sync in the beacon APIs.
Yeah, this PR proposes to introduce two endpoints. The idea of these two endpoints came out of a discussion in Discord, Allcore Devs channel with Mike, Adrian, and Paul, probably some other members of the community. But the idea of these two endpoints is to allow for the following separation of concerns. There are state providers that provides a state at a finalized checkpoint within weak subjectivity period, but this finalized checkpoint is on the choice of the state provider. So it may be like the most recent finalized or the previous one. It can be updated on the place that the state provider choose. And the other endpoint is for trust providers. So they expose the tiny API to verify that the block root from this finalized checkpoint state is matches the block root that all trust providers expose. All trust providers has. So we basically request the state first. Presumably, it's like the most recent, the state of the most recent finalized checkpoint. Then you take a slot from this state, from the block header that is in the state, take the slot, ask as many trust providers as you have about the finalized block root in this slot. If they all agree on this route, and if this route actually matches the one that you can compute out of this state that you have just pulled off, then you're free to start syncing from this like checkpoint. Yeah, the idea is to make this checkpoint sync easier for state providers and increase the the number of state providers in the network, so increase the adoption of the checkpoint sync from that standpoint. And yeah, if Adrian or anybody else can want to elaborate on that, yeah, free to chime in.
Yeah, I agree. This is good. I agree that it's the most sane way to do kind of multi-verification when you're doing this bootstrapping. And we can take it to the API repo. I guess my one concern is defining it in the API repo where that API generally is not expected to be exposed publicly, and then having a namespace that is. And I just want to be very careful when we're making that decision, if we make that decision, to kind of couple these things, just because it might result in more users exposing, accidentally exposing endpoints that are easy to be DOSed. But nonetheless, I like the pattern a lot.
Is the trust endpoint easy to be DOSed, or just the state endpoint?
Well, I guess what I'm saying is the rest of the API and the beacon APIs, those are user APIs, you know, which all of them are easy to be DOSed. You know, it's stuff that you just don't write in such a way that it's like hardened like a P2P interface. So just having it in the same kind of definition makes me a bit worried. But or you could also put big bolded, if you're using this namespace, this is, you know, be careful.
Yeah, I think that's a reasonable argument for putting it somewhere else, and in particular, the trust provider. Like, we really want as many people exposing that as possible, and so making it very easy for an operator to expose that without exposing everything else feels like a win.
Yeah, so I think everything that's been said is spot on, but also I think it's useful to be able to see those two APIs as kind of a separate thing as well. So like you're not expecting to provide the whole API. They are kind of a concept in themselves, and some of the details of how you'd implement them particularly as a state provider might differ to what a beacon node would expose directly, because you could add caching or not pull the state as regularly, that kind of thing. It doesn't have to be the latest finalized. So I think that's just a matter of making it clear in the description, and I need to read that a bit more carefully. But generally, it looked good, and I think the APIs make an awful lot of sense and should work really well. Probably the only catch with it is that it does bake in the idea of being able to start from a single state, which is possible, but it is a bunch more work for people, for clients that haven't gone that far yet, and are using a state and the block that goes with it. A couple of clients have some extra conditions on exactly which finalized checkpoint needs to be used and that kind of thing as well. So I don't know how much that's a problem for other clients, or whether they were planning to get further along and make it easy, and this API can push them along, or whether we need to also provide access to a matching block or something like that.
Or it means so they have to pull the block with body, right?
Yeah, so I'd much prefer being able to just start from state. I think it opens up a lot of simplicity for observing it and a whole bunch of options. But I do appreciate it is a bunch of work.
Is there any compelling argument for not having this long term, or is the argument here just that not all the clients have this feature yet, and it may be a while before they have it?
It does have some impact into your database a bit. So there might be some arguments there. I don't know. I think once you've done the work, it's disappeared in Teku, and it's not something I ever think about again. But yeah, I don't know how that plays out in other client architectures necessarily, and whether that becomes more of a burden longer term to keep supporting this one case where you might only have a block header. That said, if you wanted to, you can get started with just a block header and connect to the network and request that full block to make the problem go away. It just depends again on how that fits into the architecture.
Should we take it to the issue and then maybe bring it up again on the next consensus layer call as we've thought about it a bit more and maybe done a bit of refinement?
Sounds good.
Cool. Can we get the same feature in the execution client?
Only if you can shrink the state by about 100 times.
If you do stateless, you don't need it at all. You just you start with the finalized beacon state and then go from there.
Okay. Yeah.
Yeah.
Oh, sorry.
Yeah, you've mentioned the probably publishing it it's already in a separated namespace, which is called checkpoint. But if there is an idea to put it separately from beacon APIs, I don't know if it makes sense. I mean, the complexity and maintaining it as a separate API. But yeah, let's just discuss this probably in Discord and then in the issue.
Yeah, sounds good. And then last thing, Mikhail, you had another comment about basically compiling TTD blocks based on some conversations on the Discord this week. Do you want to give some quick background on that as well?
Yes, this is generally to double check the one of assumptions. Yeah, and let me explain why it appeared. So we recently learned that some execution layer clients do not instantly process blocks that are not from the canonical chain. So if in particular it was the issue with Nethermind, it received terminal block A with a total difficulty, reaching the terminal total difficulty barrier, and then we have the terminal block B, which also a terminal block in terms of terminal TTD, but it had either lower total difficulty or the same difficulty as the previous one. And in this case, Nethermind and Aragon, they don't instantly process these blocks. So they just put them into the block tree, and that's it. Yeah, we had test cases for this, and we had fixes in these clients if the transition block built top of the block B will appear, then these clients will just execute all they have up to this transition block and then execute this transition block to prevent the CL from getting stuck at the merge transition block because of safe slots to import optimistically. And one related question to, I assume that every EL client do propagate every proof of work block in spite of executing it or not. like if in this case, if a terminal block B hasn't been executed, it will be propagated after verifying the proof work seal. If it's correct, it's propagated. This is very, yeah, this is also critical for the transition. And yeah, my assumption that every Yale client does this. I just wanted to double check it. If any client does not do it, like it does not propagate a block that it hasn't processed, let us know. Or you, yeah.
So I think what clients are doing is they are propagate the blocks without processing, but only to small fraction of the peers, if this is correct. And after processing, they are propagate to all peers. And I have to verify Nethermind behavior here. I'm a bit worried that we are not working in exactly in this way that we describe, but I will check.
But if it propagates a block to a small fraction of peers, but other peers should receive like this new block hashes message, isn't it?
After processing, right? Yes.
Yeah, not after, but before, despite processing.
No. Let me send link to specification.
So the way block broadcasting should work is that when an execution client receives a block, it will, I mean, a pre-merge block, it will do a proof of work verification. If that passes, then it broadcasts it to square root of peers, then actually imports the block locally, and once import succeeds, then it actually announces it. The reason it needs to actually import a block locally before announcing it is because if I announce the block to my peers and I don't have it yet imported, then when my peers actually request the block, I will not have it yet in my local chain, so I won't be able to serve it. So we do need to actually import it before announcing it to the rest of our peers. But doing the square root broadcast already propagates through the entire network. It's just these degenerate links where you have some star topology or some many nodes hidden behind some NAT gateway. Only those are actually requiring this announcement mechanism. But and as for the TTD split, at least in Geth, we have when we have transition, we have two markers. One of them is that we've left proof of work, and the other is that we entered proof of stake. Entering proof of stake means that we received a finalized block in proof of stake, so give or take 32 blocks. And we only disable block propagation when we actually finalize proof of stake. So within those initial 32 block transitional time period, we will still broadcast all the TTD blocks. So if I have 10 different TTD blocks, I will keep broadcasting and announcing them until the POS network finalizes.
Thanks. I'm curious, yeah, base to Aragon, yeah, how does it work on your end?
I think currently we have some problems, some flaws in the logic around multiple terminal POW blocks. So I'll look into improving the logic and yeah, just in making sure. I'll check how we gossip terminal POW blocks and try to improve the logic.
Got it, thanks. And Besu?
Yeah, so we have a similar behavior to disable block propagation after finalized. I'm not certain. I'm gonna have to get back with you about our behavior for gossiping non-processed blocks, though, non-canonical blocks.
Okay, got it.
Yeah, the other thing I would add to that is that it is the second finalized that we stop after.
Yeah, I want to add that from Nethermind, it's the same. We're stopping block propagation when we finalized.
Got it. Okay.
Why the second finalized?
I guess yes for base U.
Yeah.
Sorry, Micah, could you repeat that?
Why do you wait until the second finalized instead of the first finalized?
It's how we interpreted the spec.
Actually, okay, so let's not go into the spec details around this first and second. I mean, yeah, so as long as new blocks are sent to square root of number of peers, yeah, it should be fine, right? We'll have those blocks disseminated across the network, unless there are some synchrony issues. Okay.
Okay.
By the way, can I ask a quick question? Do you feel like it would be necessary at some point to specify this, the behavior around the merge in the network spec, or is it just sufficient the way it is now? I mean, we will have to remove the propagation from the network.
Alex, I can't hear you.
You're breaking up a lot, Felix, but I think we got the gist of what you were asking. Like, should we add the merge peer-to-peer behavior to the network spec directly? Mikhail?
Good question. We have this network section in the EIP, which is a bit odd because it rather should be like a separate EIP on the network track. Yeah, probably we should deprecate the block announcements and new block propagation in the spec after the merge.
I'm not sure I understood Felix correctly. Maybe the way I kind of understood him was he was asking whether we want to spec out this network behavior during the transition period for the merge. And I mean, honestly, it seems if we want, so that would, in my opinion, make sense if we wanted to support this merge transition for multiple occasions, but that doesn't really hold true. I mean, we transitioned all our networks already, or transitioning, and we will transition mainnet too. So from that point onward, the question is how long do we want to maintain this capability to transition one network into the other? My 2 cents would be that long term we should try to deprecate supporting non-transition networks. And if we can somehow make some small tool to enable spinning up an already transition networks for private networks, then that would actually be the last nail in the coffin, and then it would allow us to actually remove quite a lot of code. So my 2 cents is that we should try to push towards not supporting non-transition networks anymore. Which would also entail not having to document it.
It does seem reasonable to like be able to drop this at some point, especially if there's like more like pretty significant changes that happen to the execution layer. So, you know, things like vertical tries and whatnot, like it seems like if we can have a clean slate to start that work on, that'd be valuable.
Well, clean slate, I don't know if we ever can, because you still need to import the chain history. So clean slate would also entail somehow dropping all the ancient history. So that's
right.
a different discussion. But still, pre-merge and post-merge, at least synchronization is quite different.
Right.
And it would be nice to support both. And also the problem is that currently all the clients need to support this transition, but this will be a mechanism that will never be tested anymore. So it will be, we just test it out for the testnets now, we will do it for mainnet, and from that point onward, we will never ever test it again live. So if anyone else relies on it, I mean, it will always be like this lottery that does it still work? We don't know. We don't care. It's probably not something you want to have around for too long.
Yeah. Okay, I guess just, yeah, coming back to the TTD block gossip issue, it seems like the next step is for like the different client teams to look into what their actual behavior is and potentially make some changes to ensure that they are gossiping at least a fraction of what would be non-canonical blocks, but that are still valid TTD blocks before things are finalized. Does that sound right to everyone?
Why only a fraction?
So the spec will say basically that's the current peer-to-peer spec, where like unless you import it, you only gossip a fraction of it. I guess if they can gossip to all their peers,
I see.
that's even better.
So you're saying some clients already don't gossip all blocks, and so it's okay if you continue to do that behavior with the TTD blocks. Is that correct?
Yeah, that was my understanding, that they don't gossip to all their peers until they've imported it locally. But if they never import that block locally, they still gossip it to like the square root of their peers, and that would allow the block to propagate on the network.
Yeah, you guys were talking about different things. As far as I know, Tim was talking about not propagating every block. So every block would get propagated, but not to every peer. And Micah was talking about certain blocks not getting propagated at all.
Right, you're right. Yeah, sorry. So yeah. I was just back to like Mikhail's original issue. If you hit TTD, you get competing TTD blocks, which you don't import because their difficulty is lower than what you see as your kind of canonical TTD block. You should still gossip those to at least the square root of your peers, assuming the proof of work seal is valid. And even though that doesn't propagate them to every peer, it should be good enough in the case of multiple conflicting TTD blocks. Is that correct?
Yeah, that's correct.
Okay. Yeah.
So we want all blocks, all terminal blocks disseminated, despite of they've been processed or not. So yeah, that's important.
Yeah. And obviously, it would be ideal if clients sent that to all of their peers, but that might just be more complex. And if like the current spec, if just following the current spec, the first sending it to like a square root is good enough, then that will work.
You really don't need to send it to all peers. So that's just Ethereum never worked like that. So I think we never ever broadcast the blocks to every single peer.
Oh, got it. Okay. Does that make sense for everyone? Okay, sweet. Next up, we have Chris, I believe, from the Flashbots team to talk about the latest on the MEV-boost side. So a lot of people on the screen, so. Oh, yeah, Chris. Okay.
Yep.
Yeah, awesome.
Hey, let me start with a quick update on the release from today's Goerli shadow fork. Everything went well. We were just seeing some connectivity issues from servers in India sending the validator registrations. Like if there is 1,000 validator registrations sent at once, it's about 0.5 MB of data. And servers with slow peering might not get that data across to the relays within the default 2-second timeout. That seems rather an edge case with really bad connectivity, but still something to keep in mind that we will work on documentation on setting the batch sizes and improving or changing the request timeouts, which is by default 2 seconds. But everything worked well on the relay here. I really want to announce that we are going to open source the relay that we are running. And we are waiting for some more updates. We have to stabilize some interfaces and clean up the database structure and do a source code audit. But we'll probably release it under the AGPL license. Please chime in if you have any opinions. The idea is if AGPL that people that change it or redistribute it with changes would need to publish their changes as well, which might help lead to an active open source ecosystem. And we believe that our relay has been pretty successfully stress tested, and this should be a good starting point for other people. Yeah, so we expect that to happen early September. It needs a few more weeks, but we are committed to opening up. And on the point of opening and open source software, I think many people are not aware that we do have an open source builder and relay that anybody can run. Okay, you know what? I will, during this call later, I see some chats about licenses, and I will just create an issue in the MEV-boost repository and post this here in the chat in a bit, where everybody can chime in with their opinions about licenses. Yeah, open to discussion here. And the repository I just posted, the Boost Gef builder, this is a builder and really implementation. So if anybody is interested in just running a simple like experimental development builder and relay, this is a repository that you can use that implements all the signing, all the APIs, and the block production. I would probably not use that as a production relay because it cannot handle, it's like a single process. It cannot handle external submissions. It's probably cannot handle a lot of concurrent validator registrations, but it's a starting point for anybody that wants to play with the code. And this is the best that we have until we release the proper relay source code. Any thoughts or questions on that?
Very, very cool to hear you are going to open source the relay. So that's pretty good news.
Yeah, we are very happy about it too.
Yeah. Anyone have questions, thoughts? Okay, and yeah, I guess we can keep an eye on the MEV-boost repo for this licensing discussion because, as you said, there seems to be some strong opinion in the chat. Sweet. Okay, and then one last thing I had on the merge is basically the DAG size. So for context, the DAG is like how much like data I guess is required in RAM to mine Ethereum. And then every time it exceeds some specific amount, it makes some hardware that's mining Ethereum obsolete because they just can't store that amount. And so we're about at 5 gigs on Ethereum mainnet right now, and it's expected to exceed 5 gigs basically 2 weeks from now, which will lead to like some drop in hash rate you would expect on the network, like any kind of machine that uses a 5 gig card won't be able to mine. And I guess this kind of affects how we may want to choose a TTD for mainnet, just because, you know, if we have this drop in hash rate, it affects how long it takes to actually hit the TTD. So given, I guess, you know, the rate at which things are going, and like the fork on Goerli that's happening in the next week or so, the next all-core devs happens basically the day after this DAG size increase, so we'd be able to see the impact on mainnet hash rate. Would people feel confident potentially setting like a TTD for mainnet right then, once we have kind of this number and can estimate the hash rate? Setting it before might just lead to like bad estimations because we don't know how much we're going to lose. It might be 1% of hash rate. It might be 5. I would doubt it's something massive, you know, on the order of like 20%. That's 5 gigs. But yeah, I guess just curious about people's thoughts on that. Like, assuming we do exceed kind of this threshold right before the next Cordash calls. Yeah. Oh, and there's a good question in the chat. How much did the hash rate drop at the 4 gigs? I'm not quite sure, but we can probably see it on Etherscan. And if we can't see it, it might be a good indication that the drop is minimal. So it was block 11,520,000. Which Etherscan does not give me on the hash rate chart. So 11 million. Yeah. 11 million, that was, okay. No, that doesn't make sense. I think there's a 0 missing here, sorry. Okay, so that was December 25, 2020, that we exceeded the hash rate. And so if you look at, so on December 2020, the hash rate was going up already. So we were like in a pretty kind of uphill trend. And so it seems we had like a pretty minimal drop that was kind of back up in the past few days, but it's, yeah, it was in a world where like the hash rate was going up quite quickly. So yeah, I guess this is like a bit of a different situation. The hash rate's been kind of stable for the past month or so, and it's definitely gone down in like the past 6 months. But, you know, based on that, it wasn't something like a 10, 20% drop. So it should be like a minimal impact. Which means, you know, we could potentially choose like a TTD before, and maybe we would just hit it slightly later. Yeah, so I guess I'm curious, yeah, from client teams, like, does like around, you know, 2-ish weeks from now seem reasonable, assuming that things go well on Goerli? Yeah.
Tim, what lead time would you anticipate? I mean, working backwards, you know, if you wanted to target day X of September, then, you know, would you want to decide 4 weeks ahead, 5 weeks ahead, 3 weeks?
Yeah, that's a good question. I would like 4-ish. And the reason, you know, we've talked a lot about like these potential mining attacks where, like, you know, if there's a ton of mining hash rate that comes online, you have like TTD hit before Bellatrix. So it seems like having something where it's like, you know, we choose the Bellatrix epoch and the TTD. We give people, you know, a bit under a week to put out a release, and then you would expect Bellatrix to hit like 2-ish weeks after that, and you could aim for a TTD that's like 7 to 10 days after Bellatrix is hit. It's just hard. There's like high kind of error bands on the TTD depending on like how far you look at the current difficulty and what assumptions you make about the rate. But yeah, you could think something like 2.5 weeks before Bellatrix, which is effectively when everyone has to upgrade, and then another like 7 to 10 days, I think, before TTD gives us enough like margin so that we're quite confident we would not hit it before Bellatrix. And okay, yeah, so there is a comment also from YouTube on the ASICs, so saying that 5 gigs is actually quite a popular size for ASICs, so the drop might be more significant there. But yeah, I guess, yeah, so that means, back to your question, Ben, like, if we chose something in 2 weeks, it means clients would need a release in, you know, call it like 2.5 weeks from now. So like the week of the week of August 22nd, that would be ready for mainnet. And is that something that's like realistic? And maybe a way to flip this. Does any client team feel like this is not realistic, or that it's just like too early to tell? We can obviously discuss this on the CL call next week as well. But yeah, does anyone feel like this is like completely impossible to hit?
Now, honestly, I think we should, if everything's fine with Goerli, we should bite the bullet and do something.
Okay. And Goerli, by the way, is scheduled. I think right now it's gonna hit next Wednesday, so it might happen before the CL call next week. It might not. So I guess we'll see by then. One thing we can also do is, we can probably set like an epoch on the CL call, because that's quite fixed in time, and then wait a couple more days and agree on a TTD. If we wanted to set it even like before the All-Core Devs call, we can do it async on the specs repo once we've seen Goerli stabilize for a few days after the fork, because I don't think we'll get that. Yeah, I think on the next CL call we'll have had Goerli live for like less than 24 hours. Yeah. Okay then.
Is there anything we should try and do before that call so that we're ready? Like a lot of the times we have these conversations about TTD and we decide on a call that we should set a TTD, and then someone goes away and works it out. Then we
great question.
We shortcut it.
So we have Mario Havel on the protocol support team at the EF. He's been doing a bunch of estimations for different TTDs and like based on historical hash rates. I think it probably makes sense to have him come and talk about that on like the CL call next week, and kind of share what like some numbers could be, assuming things are looking good, and what the rationale is behind them. And he could probably share that publicly before then, so like people have a chance to review before. But yeah, we can definitely share those estimates so that like on the call everyone agrees at least of like what are like the parameters we're looking at and what's like the rough range which we're going for, and then even if we select the actual number a few days after that, people should be on the same page about it.
Yeah, I mean, I'd almost be keen on next week's call to pick the numbers we would go with once we're happy with Goerli. Then it's just a particularly if Goerli hasn't actually merged or it hasn't been long, we can give it the time, but be close to it anyway.
Yeah, and then the only potential risk of doing that is if 5 gig ASICs are a significant part of the hash rate, it kind of changes the calculation, right? Like if we lose 10% overnight, it means whatever TTD we set, we could have set 10% lower and kind of hit at the same time. But that we won't know until basically August 18th. Enscar?
Yeah, just wanted to briefly double check. So it's basically the idea that because of this 5 gigabyte issue, we would not want to, because I think, right, there was talk about scheduling like an irregular ACD call after the Goerli fork.
Right. Yeah. So we talked about
I was wondering.
Yeah, I feel like given that the drop would happen literally on the 17th, keeping All-Core Devs on the Thursday is probably like the best, because if it's like we'll have just more data between the Wednesday and the Thursday to make a call about the actual TTD if we want to set it there. So I would lean
right.
And if we want to ignore, if we want to ignore the 5 gig issue, we can probably have a number on the CL call the Thursday before, right?
Right. Yeah. I mean, I'm just. I mean, I don't know. It almost gets silly to. I could just put like a couple days back and forth, but I mean, I think every day, right? We have like I don't know what the exact number was, but I don't know. So like some two double-digit millions of dollars of issuance. So it's kind of like even if we just a week quicker, that's still a couple $100 million that we saved. So are we? Because looking at the week, right, we would probably not, if we keep on the regular Thursday All-Core, that means we won't be able to have releases out by the end of that week, of course. So that does mean that we kind of shift everything 1 week to the right. So I'm just wondering if basically this 5 gigabit issue is enough of a concern. It doesn't, to me, it doesn't seem like enough of a concern necessarily to kind of incur that extra 1 week cost, but also maybe, I don't know, we've waited for like a couple of years, we might as well wait 1 more week.
So one thing we could do,
briefly.
yeah, I agree with you though, like, you know, days and weeks for sure matter. One thing we could do is potentially set, like, agree and set some values on the call next Thursday, and then don't have client releases, like kind of schedule client releases for the Thursday after, like basically the all core devs day, and that'll give people like around 24-ish hours, like to watch, to observe if there's like a massive hash rate drop, and if we want to lower this this TTD value, and then if we did, arguably you could like lower it on all core devs, like, you know, agree to, you know, if the hash rate's gone down by 10%, just like run the numbers with the new hash rate, and, you know, maybe clients, if they're just literally waiting on that number to make a release, can release quicker. So that might be an option as well. You just set it, you assume that like the DAG size is like a non-issue, and then if it is an issue, like you kind of wait until it's exceeded before you actually put out the release, and then if it is an issue, we update it on the all core devs. Ben?
I think there's value in, never mind the TTD. I mean, that's kind of background stuff we can argue about, but I think there's value in setting a target date expectation, which I think will motivate users of Ethereum and infrastructure people and exchanges and whoever to plan and get everything ready, allocate engineering resources and so forth. So if we, irrespective of the actual number of the TTD, say, you know, we will do the merge on X of September, or plus or minus, you know, variance, but that's our target. That might help.
Yeah, and I think one way, I agree with that. I think one way to do that quite easily is on the CL call, you set the Bellatrix epoch, right? Because we can set that to a specific timestamp, and any significant, like, basically any validator and node operator should upgrade before Bellatrix hit, regardless of when TTD happens. So I think for sure on the CL call, we could set Bellatrix, and that's like the date by which infrastructure providers and users should have upgraded anyway. And then the time between that and TTD, you're just kind of waiting around because we don't want TTD to hit before Bellatrix. But I think we can probably set that on the next, we can probably set the Bellatrix epoch height on the CL call. Does that make sense?
If governance allows, then that's good with me.
Yeah, I'll let you chat with
I think
Danny.
that makes sense.
Yeah, Danny, yeah.
Yeah, I said I think that makes sense.
Yeah.
Assuming Goerli goes well and we feel the same way about dates as we do today.
Yeah. Yeah, and obviously, yeah, there's not all the CL teams on this call, so like I would, you know, EL teams seem like pretty on board, and like the CL folks we have here as well, but want to make sure that all the EL teams like don't have something that's holding them up or whatnot. But okay, does that seem reasonable to everyone? Any objections?
So to clarify, that means that next week we are assuming Goerli has actually merged. We are making a go no go decision and setting a Bellatrix epoch.
Correct. And I would also set a TTD.
At least that's the aim.
And like call it an optimistic TTD. And then you hold the client releases until we've actually exceeded like the 5 gig DAG size. If we see a massive spike in hash rates downwards because of that, we reassess on all core devs. If not, we assume those releases are good to go. And that TTD is basically the mainnet TTD. And we'll make sure to like share kind of some of the calculations or like estimations that we've been doing on TTD publicly before the CL call, so people have a couple days to review them.
Okay, sounds good.
Sweet. Anything else on the merge that people wanted to discuss? Okay, yeah, that was a lot for an hour. Okay, in that case, there's one more thing we had on the agenda. So just to share some quick background, there's a pretty big difference between how the consensus and execution layer handle specifications for Ethereum today. So we have EIPs and the yellow paper on the execution layer, and there's a Python spec on the consensus layer. And with the merge happening, it'd be nice to like potentially have a process that's a bit more similar on both sides. And so Sam Wilson and a few others have been working on an execution spec for the execution layer as well. And it's getting kind of ready. There's like some questions about if and how we'd want to use it as part of the network upgrade process. Yeah, Sam, do you want to take a few minutes and kind of walk us through where things are at and like what are the open questions right now?
Sure. So we've been building Python specification. If you haven't seen it, go look at it. It's pretty cool. We're up to Berlin. We're doing a little bit of refactoring and then moving on to London. And we're hoping to have a mainnet parity in time for Shanghai. And a couple of us, most of the people working on the specs and some of the EIP editors want to make the Python specification part of the official EIP process for core changes. And we wanted to bring that up here to see how people feel about it and whether or not, that's, in line with what core devs want or if it's not. Tim and I have a proposal on how we want to structure that change. It's linked in the agenda if you want to take a look at it. That's basically where we're at right now.
So wait, can I ask again? So the question here is, should this executable specification be a part of the e-process? In
Yes.
that you'd have to submit changes to the executable spec in the EIP.
So your audio is really bad, so I'm
I
going to
was
try and
reading it kind of different in the agenda, where it was more about like, should this be replaced?
Okay, so I think what Felix is asking is, would this replace or complement the EIP process? So maybe, Sam, do you want to take a couple minutes to talk about like how that could work? Like, what would the process be like, basically, if you had your way? Like, what would like the ideal process look like? Yeah.
Sure. So there are a couple different options. The biggest open question about that is where to put core EIPs and their associated code changes. But putting that aside for a sec, I guess my ideal vision would be to have core EIPs contain it, like the motivation, the abstract, everything except the specification section in a markdown document or similar inside the execution specs repository. And then alongside each one of those documents, you would have, in the same git commit or same branch, you'd have modifications to the code itself. So you would still write like a human documentation describing why you want to make a change, and then you'd have like a commit that describes the technical portion of your change.
I'm not sure if we still have Felix.
Yeah,
Oh, yes, he is in the chat.
Yeah, so there are obviously some downsides to this approach, and there are obviously some upsides. So the biggest upside is that there has been a lot of ambiguity in EIPs that have led to incompatibilities between clients, and if your client isn't GPL, you can't exactly look at Geth and figure out what they're doing. So the execution specs is kind of trying to be like a neutral ground for implementing these kind of changes unambiguously. And because it's an executable spec, you can also use it to fill the tests. So you don't have to necessarily use Geth or any particular client to fill it. You can fill it with a patch that you're writing for the EIP.
Yeah, Trent has a question in the chat about integrating the ELCL process. I guess, it's worth noting the CL process is basically the opposite right now. So the CL process is PRs to the spec without this like markdown, EIP, I guess English portion that we have on the execution side. One thing that would be nice is like adding that to the CL process, but that they can be kind of different processes, but having something that's where somebody who wants to write a change that either goes across both or a change in each doesn't feel like it's two completely different processes, even though there might be quirks to one of them, like they don't need to be 100% aligned.
And I'm sure there's an edge case here, but I don't immediately see a reason to like integrate the build and integrate the software of these two specifications. And instead, if we wanted, you kind of release them as packages and allow the consensus layer to call those functions if you wanted to run them in tandem. But I don't think that, although I think the consensus layer specs how they're formatted and how we handle branches and handle new features and that kind of stuff, I think we could converge on something. I still think I'd keep them as separate repositories.
Yeah,
that makes sense. I mean, we could probably, migrate to using the same tooling for both. That way you don't have to learn two different sets of tools, but keeping them separate or together, it doesn't make much of a difference.
And, I will say, very biased, I've been working on executable specs for quite a while. I do find it really, really nice that when I'm specifying things, I'm also writing tests. And when I'm writing those tests, they also generate tests for client teams to run. And it's just the testing being so tightly coupled to writing of specifications has been, I think, really valuable to our process. But, it's a different process.
So Greg is here, and he's definitely one of the biggest opponents to this change. So I don't want to speak for him, but some of the big things he's brought up are. Do you want to talk, Greg? Because you're more than welcome to.
Opponent's not really the right word. I'm very much in favor of there being an execution spec. The CL process is what it is, and they've been basically running pretty quickly with this single client that they're working on, and the EL layer has been working differently for a long time. A lot of different clients proposals come in at different levels of doneness from people working on different clients in different languages. So I don't see that we can pull all of that together right away, but I think there should be an execution client and a team that maintains it. And that team should do what they can to keep it aligned to the EIP process. So you can look at the execution client and say, yes, these are the changes that were put in to support that EIP, work with the EIP authors, but it's not till the EIP goes final that you really can have those things aligned. The EL layer doesn't work such that everyone making a proposal is going to know how to make changes to the Python client. It just doesn't work that way.
So is Python familiarity a problem for a lot of core devs?
It just isn't, like for me, it's not worth it. The parts of the VM I care about, I know the yellow paper very well, and I can reason directly from the yellow paper for what I'm doing. And learning how to put things into the Python client is just a whole nother level of work that's not worth it to me. If I'm going to implement it, I'm going to do it in EVM1 or in Gath, so it's actually useful to somebody on mainnet. And so I have numbers for performance that mean something to me.
Andrew has his hand up.
Yeah, so about the yellow paper, because
Oh, it's
I've been
great.
updating it for
Hey,
for a number of releases, but I'm running out of steam, and I'm not sure whether I'll be able to update it to London, and probably not for the merge to Paris. So I'm just thinking that yellow paper, unless somebody picks that mantle, that yellow paper will become obsolete.
Can I ask a quick thing? So I'm sorry for the audio.
It's better now.
The issue, maybe the question would be, what area of the spec is covered by the executable spec? For example, the EVM, it has been very stable. And the most complicated thing there is things like the gas rules and like exact pricing of opcodes depending on state and things like that. These things are very tricky. And I think it would be nice to have an executable spec for that. But then there's the question, like, how much, like, is that all? Is that what it's going to be about? Or like, where does the responsibility of the executable spec end?
So I'm not like currently, and I'm not talking like theoretically, but currently the executable spec, you give it a block and it will tell you if it's valid or not. So it does, all of the gas rules, all of the Hashimoto stuff. It does everything along those lines, and then it doesn't handle reorgs. It expects to get the canonical chain one block at a time.
And it doesn't do networking or anything?
No.
Yeah, I don't think it would really be possible with the networking, but the question would be more like, so this is basically the state transition, or
yeah, exactly.
Like the state transition is there, and then also, yeah. Well, I mean, this is pretty good. Like, this is the part that I think can realistically be specified in this way. Anything that goes beyond that, like, for example, I know like most of these things are now anyway taken care of by the CL. So yeah, I guess it's pretty good.
Right, and you can imagine stuff like sync, obviously, like snap sync or whatnot, is not going to be specified there, right?
Yeah, it's not a good fit, I think, for
exactly,
the executable spec format. Yeah.
Yeah, and even like JSON RPC, and even if you look on the CL side, they have a separate networking spec. They have the beacon APIs as well. So it's like, yeah, it's really about this core state transition.
Yeah, so I'm in favor of this. I'm in favor of like trying this. Like, if we can get, what's missing are there resources missing to get the spec like the executable spec finalized, or is it on track?
No, or we're on track, I think. I think it's mostly just figuring out if we want to use it as part of the governance or not, and I think that's the big open question.
I think on that front, like one idea that had been floated before is that for Shanghai, we can maybe run both processes in parallel. So we get like call it like a test drive of the execution spec. And like and it might be, it might look something like people have EIPs already and like we just like copy them there and like, kind of mimic what an EIP in the executable spec would look like. And see, how we like that. Yeah. And then, okay, so yeah, Trent has a question about EIPs for CL and no EIPs for EL. So this is, I think that if you accept that like we do want to move to something like an executable spec, then the biggest question is like, do we keep using core EIPs like in the EIP repo and simply link the executable spec from them? So you could imagine like an EIP as it exists today, but the specification section is just replaced by a link. And you could imagine doing this on the CL as well. So like we keep core EIPs and they are where you describe the rationale, motivation, and whatnot. But when you look at the specification section, it's literally just a link out. And this has the benefit that basically you could, the EIP process is well known. people kind of know where to go to find EIPs. And also what's neat is you could specify a single EIP for a change to the EL and CL. So you could imagine something like EIP 4844. The actual EIP has all the rationale and whatnot. And then for the spec, there's a link to the EL and a link to the CL specs, which implements the different parts of 4844. So that's quite nice. The downsides, I guess, with the EIP process is one, you then need to sync up like these different repos together. So you kind of have this change in the EIP repo that can affect kind of the change in this both specs repo and vice versa. And then there's also the concerns around like just the EIP process being very high friction, which Adrian mentioned earlier in the chat. Yeah, and so I think that is like probably the biggest question if we move from like if we try this to an how we do it. And the doc in the agenda has this section kind of with the different pros and cons about that. Yeah, Felix.
Yeah, sorry, I must speak one more time.
Yeah.
And for me, I don't really understand the difference between, like, I mean, why you're putting these two ideas, the EIP process and this new executable spec, as sort of alternatives, when isn't it more like that the executable spec gives us just another tool to describe changes?
Sure.
And I feel like that should be its role for now. We could keep everything exactly the same as it is now, but just have this additional tool to be able to express changes to the specification. And then we can see if it's so much fun using it that we feel like the E process is not needed anymore, or it becomes less important to yeah.
So when you say you keep it the same, does that mean you have an EIP and then you simply link out to the executable spec for the implementation details? Is that what you mean?
No, I would rather just include the relevant parts in the EIP. So one nice thing about EIPs in general is that they are standalone documents. So you can always judge the EIP on its own when you just read the thing. You don't necessarily have to go to another place. And that has always been a goal with EIPs, I feel, that you'd be able to, I don't know, print this document and hang it on your wall, and you'd be able to look on that in 5 years and be like, oh yeah, that was this idea. And it's like fully self-contained in this document, the description of the idea. And that's something that you lose when you link to another repository where you have some diff in some code.
Right, so I'm not sure I understand what you're proposing.
I'm not proposing something. I'm just trying to. Yeah, I'm just basically interested in exploring the options here, because you guys have been portraying it as like you'd rather, like, basically I feel like this whole executable spec is mixed up in this whole other debate of what should the governance process be like.
Yeah, fair enough.
And I feel like these are just separate things.
So I think the argument is that if you have the EIP process and the executable spec process, we now have even more work to get a change through. And the EIP process is already frustrating enough for most people. And having to do the EIP process plus something just makes it worse.
I see, yeah, Sam has his hand up
Yeah,
for a while.
that makes sense.
Oh, I don't mind waiting. I have a different topic to talk about.
Okay, sorry, so Felix, sorry I cut you off.
No, I would just made an acknowledging noise.
Okay. Denkrad, was your comment about this specifically as well?
Yeah, I guess like I would say that the current process doesn't really do a good job of actually specifying exactly the changes though. Like it's like very cumbersome. You always bring in this like reference to bring in the past. So I would actually like, why can't that be a diff? I agree that the EIP changelog should be there, but it should be more a diff of the executable spec rather than this ad hoc re-specification of what is happening because it's nowhere properly specified. then saying what changes you want to make it, and all of these like little scripts that are in there never being properly checked, and yeah, being all kind of incompatible and everything. Like that seems terrible at the moment.
Well, that's the good thing with the executable spec. You can have a tool then to have these snippets that you can actually check.
I agree.
And I feel
so
like we've already kind of
they should be anchored in the executable spec.
Yeah.
Sam?
Sure. So, yeah, I think the problem with doing diffs in the current EIP process is when you get into merging things together to make a hard fork. So each EIP would have its own diff section, and then, like, let's say we actually use like a patch file, then you would end up running into problems when you try to put them all together in the end if there's any kind of conflict. And if EIPs depend on one another, you'd have to apply them in the right order, and I think that just gets really out of hand. So in the proposal that is linked in the chat, we kind of have a branching structure, so we use Git to handle merging all of those things, but that would be kind of a large change from the EIP process. Yeah.
So I guess just like from the general comments, it seems like everyone is kind of interested in seeing how this could work. Obviously, there's a bunch of like kinks to figure out, but it probably makes sense to. Oh, sorry, Andrew.
I just wanted to say that maybe if somebody creates an EIP and also on top of that creates a pull request to the execution spec, then it might be considered as a bonus, as an extra argument in favor of that EIP. So like that person has done the extra work, so we should maybe err on the side of accepting that EIP, and that would be a nice motivation.
That can also backfire. So yeah. I think it probably makes sense to like at least try to run a parallel process in Shanghai, and see what this would look like in the executable specs. And like also for Shanghai, most of the changes we've already either like considered for inclusion or that are still kind of pending are already sort of specified as EIPs. So like, realistically, we're not going to ask people to like throw out all that work and then move to something new. But if in parallel we can like make a copy of that EIP as a potential change to the executable spec, I think that would be good. Yeah, does that make sense to people? And I guess the other thing in this is maybe more something for the CL call is like, if we do want to think about how these processes could eventually be like a bit more in line, is like, how do we have something resembling the like English portion of an EIP on the CL side, and whether that's like some change in the CL specs repo or something that's, I don't know, trialed in parallel. I think that could also be interesting to test for like the Capella portion of the upgrade. Yeah.
So before we move on, I just want to bring up a few of the other concerns that people have had about the execution specs. So one of the big ones is that you have to pick a particular algorithm when you're implementing something for the execution specs. You can't leave it specified in like math notation or as a description of the outcomes, and that might influence client developers. So that's kind of a negative. Some things are much easier to specify in English than they are to specify in code. So you might lose some of the clarity you would get by writing it in English. Yeah, and I think those are the big ones. Greg, if I missed anything else, let me know. But I think those were the two other ones that we haven't talked about yet.
Yeah, that is a big one. I've got one thing that 4 sentences of English makes it quite clear, but it's a whole page of code to actually validate it. And if you read the code, it'd be very difficult to extract the 4 sentences.
Yeah, but can't we just accept the way it's basically always worked, so that like we have EIPs as this platform where you can publish your ideas and I don't know, get feedback on them or whatever. And then eventually, once the idea is like reasonably accepted, we like put it to the spec. And then like the spec can be executable. That's really nice, but it has, I feel like, very little to do with, I don't know.
No, I'm with you exactly. I think that's exactly, right now the executable spec is what it is, and it runs in parallel. And at about the same time that everything goes final, the executable spec is ready. Like you say, it's another tool for all the clients to communicate and get on the same page. And
it's just a way to form, like, really like precisely express what you mean when you're talking about consensus changes. And I feel like that should be all the starts.
Yeah. But just to be clear, so that means you could imagine an EIP, which the EIP itself does not contain the actual specification, right? Because it just links out.
Yeah, you've read that after once you've,
Right.
You can put it in the EIP or not, but it shouldn't really be like but it's just like it's nice if you can express it in the spec language. Like if it's a change that, like, I feel like many changes can be expressed in the spec language if we have a working spec language where we can be like, oh yeah, I want to make this tweak to the gas cost, and then you just write out the new formula, and you can have a bunch of text that says why you want to make this change, and it's going to be all together. But then once everyone kind of feels like this is good, you can apply that to the actual spec, and then it's going to be in there, I feel.
And then
I think the problem with that is that every change eventually needs to make it into the spec so that you can build on top of it. So why not make the spec part of the process?
And
I mean, you can
have
have
a diff, right?
You can have spec implementation TBD, and if you actually go and implement the PR, it helps illuminate what's going on. It helps show that it builds properly. But maybe some it's delayed, some it happens quickly, depending on kind of the style of the process. Because I guess if it's a complex change and you want to get the English language out there, you probably want to be able to say stub execution so I can just like get initial feedback, I guess. I don't know.
Yeah. And then I think the question is also, what's the canonical? So imagine you have like a gas cost, like a complex gas schedule change, right? And you sort of, or like a complex algorithm, like Greg was saying, you specify something like in more of a math notation in the EIP, you link out to the executable specs for the actual implementation. If they disagree with each other in some weird edge case, which one is treated as canonical? And
so I feel in this case, the execution, like the spec should be canonical.
Okay.
And also, for example, this also solves something that we have right now, where if you have multiple EIPs applying to the same kind of thing, then they sort of override each other or start interacting with each other. And this is something that you can't really specify in the EIP. Or in a related scenario, what if you create the EIP and everything seems fine, and then much later during like hard fork testing, we run into an issue and we find that the spec needs to be changed. In this case, we'd have to right now we'd have to go back and like change the EIP. But I feel like in this new world where we actually have the spec, we wouldn't necessarily change the EIP anymore. We just keep the EIP as a sort of historical document that started the idea, but then just like fix it up in the spec so the edge case is removed or something.
Yeah,
it just creates a bunch of new possibilities that we haven't really had yet. Just having the spec, like I feel that's like the milestone we should aim for right now, is just having the spec in the first place, because we don't have that right now. Once we have that, we can see like, oh, how we, like we can just check how we integrate that once the spec actually exists and works. And
yeah, that makes sense. And I think it's like all these things we need to agree to if we move forward with this. But I think and we're kind of wrapping up in terms of time. But I think people agree that this is like a really interesting experiment. It's worth continuing. The link in the agenda has a link to an ETH Magicians thread if people want to comment about like the specifics of how this happened. But I think, it's pretty clear that people want to see this play out, at least in parallel with Shanghai. So I think, Sam, that's a reasonable next step. Does that make sense? Last thing, I guess, just as we wrap up, there is a merge community call next Friday at 1400 UTC, so Friday, August 12th. If client developers want to show up, that's always useful. And there's a few Flashbots people on the call as well. I suspect if a couple of you want to show up as well, some people might have questions about MEV-boost, and it would be good to have like experts to answer them. Again, this is linked in the agenda at the bottom. But yeah, next Friday, 14 UTC, and right before that, we'll have the CL call as we discussed to talk about the Bellatrix epoch and a potential mainnet TTD. Yeah, thanks everyone. This was pretty good.
Thanks all.
Bye.
Thank you.
Bye.
Thanks everyone.
Thank you.
Bye.
Bye.
Thank you.
Bye.